Hi, I'm Veli from Greenwood Solutions. This week we are looking at the absolute riveting area of Grid Connect signage for commercial solar system of 200 kilowatts. Yeah, I know. So after watching the presentation, you'll understand what are the applicable standards and clauses that we reference, what signs are required, and also where they go. Now, if you like what you see, hit that subscription button and let's get stuck into it. Ready, steady, go! As CEC installers and designers, we need to operate under the appropriate Australian and New Zealand standards, and this applies to commercial solar systems. Signage is very important, and with the standards constantly changing, it is vital that the installer designer keeps up. Remember, signage is there and it serves multiple purposes. It's there to inform the emergency workers of what's on site, what are the electrical dangers, and also to inform anyone involved in the system or who may be accessing that system. What are the components? What are the voltages? What are the currents? Where are they located? What are the specific details of the equipment involved? The most commonly referenced Australian standards applicable to signage on a commercial solar system include 4777.1, 5003, and of course, AS3000, the master standard. The signage applicable for commercial solar systems applies both to AC and DC equipment. The AC equipment is being the main switchboard, the meter box, the distribution boards, the inverters, the AC isolators. Signage for the DC equipment includes the solar panel cabling, DC isolators, cable tray, the output on the solar panels, both from the perspective of voltage and current, and of course the location of the equipment. So obviously the standards are living documents and are constantly being amended and changed. So we're not responsible for any changes in signage requirements. What we've presented at this point in time is as accurate as we can get based on the existing standards. Now we are looking at a specific system. It's a commercial solar system of 200 kilowatts, utilising 6 by 27 kilowatt inverters connected to a secondary protection board. The secondary protection board is connected to the main switchboard. Each inverter has 5 strings of 19 by 350 watt panels for a total of 199,500 watts. The combined array short circuit current is 300 amps and the VOC max is 950 volts. No parallel strings, no combiner boxes, fire panel and MSB and secondary protection board in switchboard room. Okay, let's get stuck into it. In this particular example, we are looking at AS4777.1, clause 6.2a. The inverters are connected to a secondary protection board, so this is where this signage goes. And there's one of them. In this case, we are looking again at 4777.1, clause 6.2b. Location again, as inverters are connected to a secondary protection board, this is where this sign goes. Main switch inverter supply. In the next example, main switch grid supply, we are looking at the same standard as previously, 4777.1, but this time clause 6.2c. Location, adjacent to main switch of grid supply in the MSB. How many? 1. Main isolator normal supply. Again, 4777.1, clause 6.2d. Location, not applicable as the IES connected to the secondary protection board, so there's 0. In this case, we are looking again at 4777.1, clause 6.4. Location, main switchboard and fire panel if applicable. How many? 0. And this is because in this situation, I'm making the assumption that the inverter locations are not difficult to find. Warning, multiple supplies. Again, 4777.1, clause 6.3. Location, main switchboard. How many? 1. This falls under DC signage and the standard is 5033, clause 5.4.1. The location for this sign is main switchboard, visible when the door is open, very important. How many? 1. Now, this is one that a lot of installers get wrong. So the short circuit current here is 300 amps. So that is the combined short circuit current of all the arrays. And the open circuit voltage is the VOC max of the string that has the highest VOC max. Very important to get that right. The next sign also refers to 5033, clause 5.4.1. Main switchboard, visible when door is open, but in this case 0 because we're not using microinverters. The next signage is the classic green PV sign. Again, 5033, clause 5.4.2. The location for this is the main switchboard and meter, and if applicable, transformer pad mounted. So in this situation, we are putting 2 of them in. The next sign, the applicable standard is 4777.1, clause 6.5c. The location is the main switchboard and meter, but how many? 0 in this case. And this applies to the installation of an energy storage system. And in this case, there is no batteries involved, so we don't need this sign. Next sign again goes back to 4777.1, clause 6.11. Location, main switchboard and meter, but in this case, there's 0. And it applies to multi-mode inverters. In this case, we have none because we have no energy storage component. This sign again talks about standalone supplies, in other words, batteries, an inverter charger, clause 6.11 out of AS 4777.1. We don't, in this case, we have none of those, so we don't have any of those signs, so 0. Standard 4777.1, clause 6.2, location, secondary protection board, how many? 1. And this talks about the relevant distribution boards the IESs are connected to. In this case, the secondary protection board, as the 6 inverters are directly connected to this, and then the secondary protection board is connected to the MSB. In this case, multiple supplies, IES shutdown procedure, location, we are talking about AS 4777.1, clause 6.7. The location is a fire panel, because in this case we do have a fire panel, and how many? We put 1 in. In this case, we have multiple signs, or we can consolidate them into one sign. And the standard is 4777.1, clause 6.7. Inverters or inverter station, we have 6 inverters, so we'll need 6 of these signs. Now, it is a grey area, and you could use 1 per inverter station, possibly. It just depends on your inspector. So effectively, a permanent sign detailing the shutdown procedure for the IES in the event of an emergency situation shall be installed adjacent to and visible from the equipment or the switch to be operated in the event of a shutdown. A warning shall be included in the shutdown procedure indicating that isolation of the energy source by shutting down the inverter and isolating the IES may not de-energise the energy source, and further actions may be required. So it's a pretty important sign. In fact, they all are. The next example again references 4777.1, clause 6.5b, and it's located at the main switchboard, but how many in this case? 0. And this is because where no standard exists for the energy source being installed, the following label should be included as a minimum. But we have a standard. And if there was batteries involved on this site, currently we do have an applicable Australian standard for batteries. So in this particular scenario, 0 of this sign. Now, demand response mode, DRM labeling, really important. So again, 4777.1, clause 6.6, location on or at each inverter, and there is 6 inverters, so 6 of these. And also, the label shall indicate the demand response modes of which the unit is capable of. It shall indicate on the label which functions have been connected and enabled. Warning, multiple energy sources, turn off all isolates to isolate inverter. In this case, again, 4777.1, clause 6.10, on or at each inverter. But how many do we need in this situation? 0. Now, when you're talking about multiple energy sources, so in conjunction with solar, you're talking about wind or battery storage, there's a whole host of signage that's required. In our case, we are talking simply grid connect, so the sign in question is not required. Warning, multiple DC sources, turn off all DC isolators to isolate equipment. 5033 is the standard, clause 5.5.2, location on or each inverter. In our case, we have 0. The reason why we have it 0 in this situation is, in our case, the inverters have a built-in DC load breaking switch, so we don't need this sign. PV array DC isolator. Again, 5033, clause 5.5.2, and also 4777.1, clause 6.8. Location at the inverter, near the built-in DC switch, and for each DC isolator on the roof. And in this case, we need 36 for them. As we're using 6x inverters, each with a built-in DC isolator, switches will be needed for 1 per inverter, and also there are 30 times strings on the roof, each with its own DC isolator. So lots of signs here, 36. Inverter AC isolator. Clause 6.9, again standard 4777.1. At each inverter, there's 6 of the inverters, so you need 6 of them. We're using 1 AC isolator per inverter, and the signage should indicate which AC isolator goes with which inverter. So inverter 1, inverter 2, inverter 3, and so on. Warning, hazardous DC voltage. 5033 is a standard, clause 5.3.2 is required. The location is the PV array and PV string junction boxes. 0, but should be attached to the cable tray carrying DC cables on roof and at the inverters. But we don't have any PV string junction boxes, but we'd have signage actually on the cable tray. Warning, hazardous voltage authorised access only. So this is Australian Standard 5033, clause 5.5.4. The location is the access door or gate, how many? 1. So this sign, hazardous voltage authorised personnel, applies to all commercial solar systems, because invariably all commercial solar systems, your string voltages are over 600 volts. In domestic, it's obviously up to 600, and when I say up to 600, I mean VOC max. This next signage is only in Victoria, so it's under the ESV requirements, clause 6.9.2.3, and the location of this sign is at the MSB and fire panel, and how many you need will be 2. And I think also if there was a transformer pad mounted, you'd put signage on that as well to indicate that this premises contains an electricity generation system. Thanks so much for watching that incredibly interesting subject known as commercial solar grid connect signage. Yeah, very tongue-in-cheek on that one. I'm Billy from Greenwood Solutions. If you have any questions, any inquiries, or even any answers, feel free to drop us a line. And if you like what you saw, hit that subscription button. And looking forward to presenting more interesting subjects. A bit more interesting than the Grid Connect signage though. Bye for now.